Welcome to the fastest way to learn data structures and algorithms with this premium revision material. Today, we are mastering LeetCode 172. Factorial Trailing Zeroes. This is a fascinating math-based challenge that often pops up in technical interviews to test your number theory intuition. Let us look at the problem statement. Given an integer n, our task is to return the number of trailing zeros in n factorial. Remember, n factorial is the product of all positive integers from 1 up to n. For example, if n is 5, 5 factorial is 120, which has one trailing zero. But for large numbers like 100, calculating the full product is impossible. We need a smarter way. Think of it like a professional lunchbox assembly line. To create a complete meal, which represents a trailing zero, we need two ingredients, a sandwich, representing a factor of 2, and a cookie, representing a factor of 5. On our belt, sandwiches are everywhere. Every even number, 2, 4, 6, provides at least one. But cookies are rare. They only appear every fifth number 5, 10, 15. Since we have a massive surplus of sandwiches, the number of complete meals is strictly limited by how many cookies we can find. Wait. Some special boxes, like 25, actually contain 2 cookies. Our goal is simply to count the total number of cookies in the entire factory. The strategy is simple. We count how many factors of 5 exist in all numbers from 1 to n. 1. We divide n by 5 to count numbers that contribute at least one factor of 5. 2. We then divide n by 25 to count numbers that contribute a second factor, then 125, and so on. The total sum of these counts gives us the exact number of trailing zeros, without ever calculating the factorial itself. Let us dive into the dry run with n equals 25. Look at the screen. We have our input n, and our result tracker starting at 0. First, we calculate 25 divided by 5. That gives us 5. These are the multiples, 5, 10, 15, 20, and 25. Each of these gives us at least one trailing zero. We update our result to 5. Next, we move to the second layer. We divide 25 by 25, which gives us 1. This represents the number 25 itself, which contributes an extra factor of 5 that we haven't counted yet. We update our result to 6. Finally, we try 25 divided by 125. That is 0, so we stop. Our final count is 6. Simple, elegant, and efficient. Now, let us look at the Python code. We initialize our count variable to 0. We use a while loop that continues as long as n is greater than 0. Inside, we update n by dividing it by 5 using integer division. This effectively moves us through the layers 5, 25, and so on. We add this new n to our count in every iteration. Once n hits 0, we return the total count. This approach is lightning fast. Looking at the complexity, the time complexity is O of log n, specifically log base 5 of n, because we divide n by 5 in each step. The space complexity? O of 1. We only use a single integer to store our count. And that is Factorial Trailing Zeroes, mastered. Save this video for your next technical interview, and follow Leo Academy for more such premium DSA guides.